Yes, we are going to start with the 6.7. Six point seven deals with the hyperbolic functions. Hyperbolic functions. Similar to the trigonometric functions, there are six hyperbolic functions. Sin hx is e to the x minus e to the negative x over 2. Cos hx is e to the x plus e to the negative x over 2. Tan hx is sin hx over cos hx. Then cot hx is a reciprocal of tan hx. Secant hx is a reciprocal of cos hx. And cosecant hx is the reciprocal of sin x. Theorem. The first theorem is cos square x minus sin square x is equal to 1. And this is there is a corresponding trigonometric identity, which is cos square x plus sin square x is equal to plus sin square x is equal to 1. Here it is minus. Proof. Left hand side is cos square x minus sin square x, and that is e to the x plus e to the minus x divided by 2 the whole square minus e to the x minus e to the negative x the whole square divided by 2, and that is e to the x plus e to the negative x the whole square divided by 4, 2 square is 4, minus e to the x minus e to the negative x whole divided by 2 the whole square divided by 4. And now you FOIL this. E to the x, the whole square is e to the 2x, then 2 times the product. In the previous section, I have shown that a plus b the whole square is a square plus 2ab plus b square. So there is a 2ab. 2ab means 2 times e to the x times e to the negative x, that is e to the 0, plus square of the second minus, similar formula here, square of the first minus 2 times the product plus square of the second. So e to the 2x minus 2 e to the 0 plus e to the negative 2x. 1/4 is already pulled out. Now e to the 2x cancels, e to the negative 2x cancels, and leaving a 2 plus 2, 4. 4 divided by 4 is 1. Then there are some other identities. Cos h negative x is equal to cos hx. That means cos hx is an even function. Sin h negative x is equal to negative sin hx. Sin hx is an odd function. Then the next one is 1 minus tan h square x is equal to secant square h. In trigonometry, you have 1 plus tan square theta is equal to secant square theta. So in this case, it is 1 minus tan h square x is equal to secant h square x. Then they add some formula. Sin hx plus y is sin hx cos hy plus cos hx sin hy, similar to the trigonometric formula, but here there is a difference. Cos hx plus y is cos hx cos hy plus sin hx sin hy. Okay, now questions. Differentiate sin hx. So let y is equal to sin hx. Sin hx is the same as e to the x minus e to the negative x all divided by 2. So you differentiate. Dy over dx is 1/2 times derivative of e to the x is e to the x minus e to the negative x times negative 1. So 2 negatives makes a positive here, and this is the same as cos hx. And the derivative of cos hx, y is equal to cos hx, that is equal to e to the x plus e to the negative x divided by 2. When you differentiate, you get dy over dx is equal to e to the x minus e to the minus x divided by 2, because derivative of e to the x is e to the x plus e to the negative x times negative 1. So that becomes a negative. So that's the same as sin hx. Then tan hx. Tan hx is sin hx over cos hx. So you use the quotient rule here. Dy over dx is the denominator times that is cos hx times derivative of the numerator. Derivative of sin hx is cos hx minus numerator times sin hx times derivative of cos hx, that's sin hx, all divided by the square of denominator. It becomes cos square minus sin cos square x minus sin square x divided by cos square x, which is 1 over, because by theorem cos square x minus sin square x is 1. So this is 1 over cos square x, which is secant h square x. Secant hx. Secant hx is 1 over cos hx, and you are using the chain rule here. Dy over dx is negative 1 over cos square x times sin hx. So that is negative 1 over cos hx times sin h over cos hx. It's negative secant hx times tan hx. So we are applying chain rule. You may use the quotient rule also, that it doesn't matter. Number 5, y is equal to cosecant hx sin hx. Cosecant hx is the same as 1 over sin hx. Therefore, dy over dx is negative 1 over sin square x times derivative of sin hx, that is cos hx. And so, negative 1 over sin x times cos h over sin hx, that is negative cosecant hx minus cot hx. Cos hx divided by sin hx is cot hx. Cot hx, that's the last one. That is cos hx minus sin hx. You see, quotient rule, denominator times the derivative of the numerator. So sin hx times sin hx minus cos hx times cos hx divided by sin square x. Numerator is sin square x minus cos square x. You pull out a negative sign out of that. So it becomes negative cos square x minus sin square x all divided by sin square x. And that is 1 over sin square x, negative 1 over sin square x. That is negative cosecant h square x. Okay, now a few more results. Oh no, this is a question from textbook. 2a. Evaluate tan h0. Tan h0 is e to the 0 minus e to the negative 0 divided by e to the 0 plus e to the negative 0. That is 1 minus 1 divided by 1 plus 1. That is equal to 0 over 2, which is 0. B part, tan h1. That is e to the 1 times minus e to the negative 1 divided by e to the 1 plus e to the negative 1. You multiply numerator and denominator by e, you get e square minus 1. E to the negative 1 is the same as 1 over e. So e cancels. You get a 1. So e square minus 1 divided by e square plus 1. Number 4. Sin h4. You are asked to evaluate sin h4. So that is e to the 4 minus e to the negative 4 divided by e to the 4 plus e to the negative 4. To simplify it, you multiply numerator and denominator by e to the 4. So it becomes e to the 4 plus 4, that is e to the 8 minus e to the 0, which is 1, divided by e to the 8 plus 1. There. Sin hx, sin h natural log 4. So this is e to the natural log 4 minus e to the negative natural log 4 divided by e to the natural log 4 plus e to the negative natural log 4. So that is equal to 4, because they are inverses to each other, and 4 minus e to the power of natural log of 1 over 4, because assuming that there is a negative 1 here, there is a 1 there. So it is negative 1, it becomes 4 to the negative 1, that is natural log of 1/4. So it is 4 minus 1/4 divided by 4 plus 1/4, because these two are inverses to each other. So it is going to be 1/4. Now multiply by a 4 over 4, you get distribute, you get 16 minus 1 over 16 plus 1, which is 15 over 17. Number 6. Sin h1, that is e to the 1 minus e to the negative 1 whole divided by 2. Multiply by e over e. When you multiply by e over e cancels, so it becomes e square minus 1 over e. B part. Sin h inverse 1. So this is how you approach there. Let x is equal to sin h inverse 1. Therefore, sin h x is equal to 1. Sin h x is equal to 1. That is e to the x minus e to the negative x divided by 2 is equal to 1. Multiply by 2, e to the x minus e to the minus x is equal to 2. So it becomes e to the x minus 1 over e to the x is equal to 2. Multiply by e to the x, you get e to the x the whole square minus 1 is equal to 2 e to the x, that is equal to u square minus 2u minus 1 is equal to 0. That is because we assume that u is equal to e to the x. So if u is e to the x, this equation becomes eu square minus 1 is equal to 2u. Move the 2u to the left and use the quadratic formula here. You get u is equal to 2 plus or minus 4 plus 4, that is negative 2 the whole square minus 4 times 1 times negative 1. Square root of 8 is 2 square root of 2 and 2 cancels. The answer is 1 plus or minus square root of 2. That is e to the x is equal to 1 plus square root of 2 or 1 minus square root of 2. Negative is not valid. 1 minus square root of 2 is a negative number. E to the power of anything cannot be negative because the range of e to the x function is 0 to infinity. So this is not valid. So the actual final answer is e to the x is equal to, that is u is equal to, e to the x is equal to 1 plus square root of 2. Therefore, x is equal to natural log of 1 plus square root of 2. Okay, so here I have skipped a couple of steps. What you have to do is, I'm going to explain once again. It's sin h1 is equal to e to the 1 minus e to the negative 1 over 2. Now you multiply numerator and denominator by e, you get e square minus 1 divided by e, and that is the value of sin h1. Yeah, b part, sin h inverse 1. So let x is equal to sin h inverse 1. So sin hx is equal to 1. That is e to the x minus e to the negative x whole divided by 2 is equal to 1. Multiply by a 2, you get e to the x minus e to the negative x is equal to 2. Now you e to the negative x is 1 over e to the x. So e to the x minus 1 over e to the x is equal to 2. Multiply by e to the x. E to the x the whole square minus 1 is equal to 2e to the x. Now you call e to the x as u. If e to the x is u, this equation becomes e to the u square minus 1 is equal to 2u. Now subtract a 2u. It becomes u square minus 2u minus 1 is equal to 0. You use the quadratic formula and ultimately you get u is equal to 1 plus or minus square root of 2, means e to the x is equal to 1 plus or minus square root of 2. 1 minus square root of 2 is negative. E to the x cannot be negative, so that's not valid. Therefore, e to the x is equal to 1 plus square root of 2. That means x is equal to natural log of 1 plus square root of 2. Number 8. You have to show that cos h negative x is equal to cos x. Left hand side, cos h negative x. So that is e to the negative x plus e to the negative of negative x, because cos hx is e to the x plus e to the negative x. So that means you replace x by negative x, it becomes negative x plus e to the negative x. negative of negative x is positive x, which is the same as e to the x plus e to the negative x over 2, which is cos hx. Number 10. Prove that cos hx minus sin hx is equal to e to the negative x. Left hand side is cos hx minus sin hx, that is e to the x plus e to the negative x divided by 2 minus e to the x minus e to the negative x whole divided by 2. You pull out a 1 half, so 1 half times e to the x plus e to the negative x. Now you distribute the negative sign, minus e to the x plus 2 negatives makes a positive plus e to the negative x. E to the x cancels, so you have e to the x, e to the negative x plus e to the negative x, that is 2 e to the negative x divided by 2. Answer is e to the negative x, and that is the right side. Then cos x plus y is equal to cos hy, cos hx, cos hy plus sin hx, sin hy. Right hand side is cos hx, cos hy plus sin hx, sin hy. That is e to the x plus e to the negative x divided by 2 times e to the y plus e to the negative y divided by 2 plus sin hx is e to the x minus e to the negative x divided by 2 times e to the y minus e to the negative y divided by 2. 1/4 is common because 2 times 2 is 4. 2 times 2 is 4. Pull out the 1/4. Once you pull out the 1/4, you get e to the, foil this, e to the x times e to the y is e to the x plus y. E to the x times e to the negative y, e to the x minus y. E to the minus x plus e times e to the y is minus x plus y, which is y minus x. And similarly, e to the negative x times e to the negative y is e to the negative x minus y. And here also same terms. And now some of the terms cancels. So e to the x minus y cancels with e to the x minus y. E to the y minus x cancels with e to the y minus x. So leaving, you have 2 e to the x plus y. You have an e to the x plus y here and here, plus 2 e to the negative of x plus y, negative x minus y, and that is 2 is pulled out, 2 over 4 e to the x plus y plus e to the minus x minus y, and pull out a negative from this. You get e to the x plus y plus e to the negative of x plus y divided by 2. That's the same as cos x plus y, cos x plus y, and that's the same as the left hand side. If tan hx is equal to 12 over 13, find the value of other hyperbolic function. First I'm going to work out the direct method, which is a little long in nature. Tan hx is equal to 12 over 13, that is e to the x plus e to the negative x, e to the x minus e to the negative x whole divided by e to the x plus e to the negative x is equal to 12 over 13. Let e to the x is equal to u, so e to the negative x is 1 over u. So this becomes u minus 1 over u plus divided by u plus 1 over u. Multiply both numerator and denominator by u. You get u square minus 1 divided by u square plus 1 is equal to 12 over 13. Now you cross multiply. 13 u square minus 13 is equal to 12 u square plus 12. That is u square minus 25 is u square minus 25 is equal to, where is that? No, sorry. you subtract a 12u square and add a 13 on both sides. You get u square is equal to 25. That is u is equal to 5 or minus 5. But it cannot be negative because u is e to the x. E to the x cannot be negative. So discard negative 5. You have e to the x is equal to 5. E to the negative x is 1 over e to the x. That is 1 over 5. So sin hx is equal to e to the x minus e to the negative x over 2, which is equal to 5 minus 1 over 5 divided by 2, multiply both numerator and denominator by 5, you get 24 over 10, which is 12 over 5. Cos hx is equal to e to the x plus e to the minus x divided by 2. So 5 plus 1 over 5 all divided by 2, multiply by a 5 over 5. You get 25 plus 1, that is 26 over 10, that is 13 over 5. Cot hx is the reciprocal of tan hx, so it is 13 over 12. Secant hx is the reciprocal of cos hx, that is 5 over 13. Cosecant hx is the reciprocal of sin hx, that is 13. Where is that? I'm sorry, there is a mistake here. Yeah, it's not. Sin hx is actually 12 over 5. So this is a 12 over 5, not a 13. Therefore, the answer is 5 over 12, not 13 over 2. Sorry about that. So you have to fix it. This is a PDF document, so I cannot correct it. And so the answer is 5 over 12. Second method, or it's a shortcut. So you are given tan hx is equal to 12 over 13. Now you divide numerator and denominator by square root of 13 square minus 12 square. That denominator square minus numerator square. This is square root of 169 minus 144, square root of 25, that is 5. So you multiply numerator and denominator by 5. You get 12 over 5 divided by 13 over 5. Therefore, sin hx is 12 over 5, cos hx is 13 over 5. So this is the easiest way. Then you find the other functions. Now, next. Evaluate limit x approaches infinity, tan hx. That is limit x approaches infinity, e to the x minus e to the negative x divided by e to the x plus e to the negative x multiplied by e to the negative x. You get e to the negative x over negative x. You get e to the 0 minus e to the negative 2x divided by e to the 0 plus e to the negative 2x. E to the 0 is 1. So it is 1 minus e to the negative 2x divided by 1 plus e to the negative 2x. E to the negative infinity is 0. So this becomes 1 minus 0 divided by 1 plus 0. That's equal to 1. B part. Limit x approaches negative infinity, tan hx. That is limit x approaches negative infinity, e to the x minus e to the negative x, all divided by e to the x plus e to the negative x. Multiply numerator and denominator by e to the x. So you get limit x approaches negative infinity, e to the 2x plus minus 1 divided by e to the 2x plus 1. So that is x is negative infinity. So this is e to the 2 times negative infinity minus 1 divided by e to the 2 times negative infinity plus 1. So that is 0 minus 1 over 0 plus 1. Answer is negative 1. C bar. Limit x approaches infinity, sin hx. That is limit x approaches infinity, e to the x minus e to the negative x, or divided by 2. That is e to the infinity minus 0 over 2, which is infinity. Secant hx, no, that is, yeah. Limit x approaches infinity, secant hx. Secant h is the reciprocal of cosine. So limit x approaches infinity, 2 over e to the x plus e to the negative x. That is 2 over e to the infinity plus e to the negative infinity. That is 2 over infinity plus 0. So 2 over infinity, which is 0. Next, limit x approaches infinity, sin hx over e to the x. Sin hx is it is calculated here. Sin hx over e to the x is e to the x minus e to the negative x over 2 divided by e to the x, means e to the x plus 1, multiplied by the reciprocal, you get e to the x minus e to the negative x over 2 multiplied by 1 over e to the x. That is e to the x over e to the x is 1. So you have a 1 here, minus e to the negative x divided by e to the x is e to the negative 2x over 2. So sin hx over e to the x is 1 minus e to the negative 2x over 2. So limit x approaches infinity, 1 minus e to the negative 2x over 2. X is infinity, e to the negative infinity is 0. So that is 1 minus 0 over 2 is equal to 1 half. Next, prove that cosecant inverse x is equal to natural log of x plus square root of x square minus 1. Let cosec inverse x is equal to u. So cosec u is equal to x. That means e to the u, that's the definition of cosec function. E to the u plus e to the negative u divided by 2 is equal to x. Multiplied by a 2, e to the u plus e to the negative u is equal to 2x. Let e to the u is equal to t. So e to the negative u is 1 over t. So t plus 1 over t is equal to 2x, where t is equal to e to the u. That means t square plus 1 over t is equal to 2x. So t square plus 1 is 2xt. T square minus 2xt plus 1 is equal to 0. That implies you are applying the quadratic formula here. T is equal to 2x plus or minus square root of 4x square negative 2x the whole square minus 4. That is 2x plus or minus square root of 4 times x square minus 1 whole divided by 2. That is 2x plus or minus 2 times square root of x square minus 1 whole divided by 2. 2 cancels. T is equal to x plus square root of x square minus 1. But t is e to the u. So e to the u is x plus square root of x square minus 1. So u is natural log of x plus square root of x square minus 1. And what is u? U is cosec inverse x. So cosec inverse x is natural log of x plus square root of x square minus 1. I know the proof is slightly confusing, but just I'll explain once again. First, you assume that cosec inverse x is equal to u. So cosec u is x. You apply the definition of cosec u. E to the u plus e to the minus u is equal to 2x. For convenience sake, you call t is equal to e to the u. So this is t plus t to the negative 1, which is 1 over t, is equal to 2x. Multiply, and you get a quadratic equation here. Use the quadratic formula, and finally replace t first and then replace u. Okay, next is inverse hyperbolic functions. Y is equal to sin h inverse x. X is equal to sin h y. Dx over dy is cos h y. So that is square root of 1 plus sin square y. See here is the identity. Cos square y minus sin square y is 1. So sin square y is cos square y minus 1. So this is uh, minus 1, and also cos square y is 1 plus sin square y. So this is square root of 1 plus sin square y, that is square root of 1 plus x square. Therefore dy over dx is 1 over square root of 1 plus x square. Cos h inverse x. Let x is equal to cos hy. Therefore dx over dy is sin hy. That is square root of cos square y minus 1. See here, sin h square y is cos square y minus 1. And that is equal to square root of x square minus 1, because cos hy is x. That is square root of x square minus 1. So the dy over dx is a reciprocal of that. That is square root 1 over square root of x square minus 1. Tan h, it's not tan, it is tan h square. So that is missing. H is missing there. I'm sorry about that. Y is equal to tan h inverse x. So x is equal to tan h y. Dx over dy is secant square y. Secant square y is 1 minus tan square y. See, look at this. 1 minus tan square is secant square. So that is 1 minus tan square y. That's 1 minus x square. Dy over dx is 1 over 1 minus x square. Tan inverse. It is tan h inverse, not tan inverse. You know, derivative of tan inverse x is 1 over 1 plus x square. I'm sorry about this. It is a tan h inverse x. Wow, fifth one. Y is equal to secant h inverse x. So x is equal to secant hy. Dx over dy is negative secant hy times tan hy. We have seen the derivative there. That is negative secant hy times square root of 1 minus secant square y. Here it is, 1 minus secant square y. That is negative x times square root of 1 minus x square. So dy over dx is negative 1 over x times square root of 1 minus x square. Okay, you try the other two by yourself. Next is find the derivatives. Gx is equal to sin square x. This is question number 32 from the book. So g prime x is equal to, you use the product, the chain rule, 2 times sin hx times the derivative of cos hx. So that is 2 times sin hx cos hx, which is the same as sin h 2x. 34. Ft is equal to natural log of sin h t. Chain rule again, 1 over sin h t times cos h t. This is cottage t. 36. Y is equal to secant hx times 1 plus natural log of secant hx. So dy over dx is equal to secant hx times, you are using the product rule. So secant hx times derivative of the second one. Derivative of 1 is 0, so you must skip it. 1 over secant hx times negative secant hx times what is the derivative of secant hx? That's right. There is a negative sign. Negative secant hx times tan hx. Secant hx times 1 over secant hx times derivative of secant hx is negative secant hx times tan hx plus 1 plus natural log of secant hx times negative secant hx times tan hx. So secant hx cancels here. So you have negative secant hx times tan hx minus, distribute this, minus secant hx times tan hx minus, this is again negative, natural log of secant hx times secant hx times tan hx. That is negative 2 secant hx tan hx when you combine these two minus natural log of secant hx times secant hx times tan hx. Pull out the common factor, negative secant hx tan hx times 2 plus natural log of secant hx. Next, antiderivative of 1 plus sin x 1 plus 4x dx. One way to work out this problem is you substitute 1 plus 4x is equal to u and then use the u substitution. But I did not do that because this is a linear function. So if it is a linear function, what you have to do is you find the antiderivative of sin hx is cos hx. So it is cos hx of 1 plus 4x and divide that by the coefficient of x. The reason is if it is a multiplication, sorry, if it is a differentiation, you multiply by a 4. That is the chain rule. And integration is the reverse process of differentiation. So instead of multiplying, you have to divide. But the best way is you substitute 1 plus 4x is equal to u and then proceed. After 2 steps, you get it. Then 62 integral tan hx dx is sin hx over cos hx dx is equal to natural log of cos hx plus c because numerator is the derivative of the denominator. If the numerator is the derivative of the denominator, then the answer is the natural log of the denominator. And here, again, integral secant h square x divided by 2 plus tan hx. This again, numerator is the derivative of the denominator. So the answer is natural log of 2 plus tan hx plus c. If the numerator, it is discussed here. If the numerator is the derivative of the denominator, then the antiderivative is the natural log of the denominator. So, yeah, these results are from trigonometry. Not these results are from trigonometry. That is not discussed here. Okay, that's all. Okay, please go through it, work out the homework assignment problems, and if you have questions, come to the online tutoring when I am online. Okay.